Okay, so welcome to the 5th virtual office hours, which we are holding today on Wednesday, the 18th of June, 2014. What I'll be doing as usual, as is our custom in these virtual office hours, I'll start out by going through my solution to the week 4 assignment number 3, and then we'll take your questions from week 4 assignment 3. We'll also talk about week 5 assignment 4. I'll go through the skeleton of that, and of course we'll also answer any questions you may have about any topics that relate to the class, to the assignments, to the quizzes, to the World Cup, anything else that's on your mind right now. So let's go ahead and start first by looking at the solution that I came up with for assignment number 4, or assignment number 3 from week 4. And let's start by sharing my screen. Hopefully this will work. It looks like it is. Yep. Okay, good. So when we talk about this assignment, what we're going to observe, of course, is that you had to reuse some of the stuff that you had for last time. In particular, you had to reuse your simple semaphore implementation. Ideally, you watched virtual office hours from last week where I went through my solution in great detail, and we talked about many different ways to implement the solution correctly. We talked about a lot of different ways to implement the solution incorrectly, and hopefully everybody updated their solution so it worked properly. A couple things to note. First of all, if for some reason you struggled to get your solution to work, you can still do week 4 assignment 3 by simply replacing simple semaphore with semaphore, because the interface and the semantics are identical. So you should be able to at least test out your solution. If you had some quirks or problems with your simple semaphore, you can still test it. And secondly, some people have asked, why do we reuse these solutions from week to week? Well, obviously the reason for this is to mimic the kind of thing that you do in real life when you build reusable software. If you build reusable software, then you build it, and then the idea is to reuse it multiple times. So the motivation here was to get to the point where people would go back, take the steps necessary to improve what they had, and then reuse it for the future implementations. This, of course, is very consistent with what we do here at Vanderbilt for the courses we teach. Many of the class projects build on each other week by week, and that's a way to ensure that the students keep up with what's actually going on in class. And it also gives them some good principles about reuse. So let's go ahead and take a look at the application that actually uses all this stuff. This is the Ping Pong Write application. And as you can see here, Ping Pong Write, I gave you a lot of the pieces for Ping Pong Write. So you should have that available. And let's start by taking a look and seeing how it works. So Ping Pong Write is a public class. It's got a couple of things in it that are useful. There's this thing called max iterations, which may be not so useful, but I kept it in here to avoid confusing people by taking it out. We also have a countdown latch. The countdown latch is going to be used by the different threads in order to do their thing, in order to be able to coordinate when we exit. We'll talk a lot more about the countdown latch shortly and what its role is and so on and so forth. We'll also talk about why we used countdown latch here instead of using thread join, which is another alternative way of doing more or less the same thing. And we'll talk about why we use countdown latch. And now we have the main workhorse portion of this implementation. This is called play ping pong thread, which extends thread. And in this particular solution, I went ahead and used an array of 2 elements. It was not required to use an array of 2 elements. You can also use 2 semaphores. I just felt this was easier for me to understand, but it's perfectly okay if somebody doesn't do it this way as long as their solution works. We'll talk in a minute, by the way, about whether you can get away with using a single semaphore. I strongly advise against trying to do that, but you're welcome to give it a shot, although it probably won't work for this assignment. Then we have another thing that keeps track of the iterations. That was probably redundant with the one we had before, but that's all right. It's not the end of the world. Here is the first thing that you really have to fill in. You have to fill in some kind of string that's used to print whatever the message is, ping, pong, A, B, whatever it is. In fact, think I'll say, for example, Ping or Pong, since it could actually be A or B based on the test driver. And basically, you just have to have a private final string, which is the string to print. The next thing you need to do is define two simple semaphores that can be used to alternate printing of the pings and pongs. You can use an array of semaphores or just define two data members. As you can see here, I defined an array of two simple semaphores, but you're welcome not to do that if you don't want to. Down here, we have the actual implementation, which, as you can see, the constructor is really quite simple. In fact, we could probably make this final, since it doesn't change once we've assigned it. It just stays that way. As you can see down here, the constructor of play ping pong thread assigns the string to print, it assigns the iterations, and it assigns semaphore 1 to first semaphore and semaphore 2 to second semaphore in the two-element array. And we'll look at where this actually gets called later to see how it sets those semaphores up correctly. Here's the run method. This is the workhorse of the whole thing. As you can see, it basically just runs inside of the run method, which means it's running in its own thread of control, assuming you started the threads properly, of course. And what it does is it just loops the number of iterations that you gave it. And each time through the loop, it acquires the semaphore, prints out what needs to be done, the string, either ping or pong, etc., and the loop count. And then it releases the semaphore, except it's releasing a different semaphore than the one it acquires. We'll look at that in a second. And the final thing it does, no matter how it exits from this, whether there's an exception, which, by the way, shouldn't be occurring, but if there was an exception, we would make sure that we always decrement the countdown latch by 1. So we put the whole thing in a try finally block. Now, you could probably argue that there are no exceptions thrown in this context, and you would probably be right. So the try finally block is probably optional, but I've tried to get in the habit as much as I can when I program in Java to future-proof myself from modifications. If I were to go back here and add some other statements that might end up throwing exceptions, then I would be in for a big surprise if I didn't have that try finally block. We'll talk a bit more about this. Some people, for some reason, ended up doing a countdown every time through the loop, which is not necessarily wrong. If you set the countdown latch to the right value, it'll work properly, but it's overkill. You don't need to do that. So I wouldn't count off if somebody did it, but I would leave a comment saying you don't have to count down each time through the loop. That's not strictly part of the requirements. So that's the run method. Here's the acquire method. As you can see, the acquire method simply grabs the lock uninterruptedly for the first semaphore, so that goes ahead and grabs it, or blocks, waiting for it to be acquired. And the release method always releases the second semaphore. And this is basically the ping-pong metaphor. We have these two semaphores, and they alternate letting each other go. And of course, one will start out locked, and the other will start out unlocked. And we'll look at that to see how that happens in just a second. So that's basically how things work. Acquire and release, they don't throw any exceptions. We call acquire uninterruptedly, which hopefully you implemented correctly in your simple semaphore solution, so it should work properly here. So it's a good example of systematic reuse, a very small example of systematic reuse, but a nice example nonetheless. Now, some people ask the question, why do we call acquire and release? And the reason for this, of course, is because we're gearing ourselves up for the next assignment, where we actually do something more interesting than this assignment. This assignment kind of hard codes the use of semaphores. The next assignment leaves that as a late binding decision using the magic of virtual methods and the template method pattern. And we'll talk more about that when we talk about the skeletons for the next assignment shortly. So that's acquire and release, that's run, pretty straightforward. Here's now the main method called process. As you can see, it passes in a bunch of parameters, which you should use, by the way, in order to be able to print things out correctly. So here's what it does. It starts out by creating a new countdown latch, and if we're probably really being right here, we should say, you know, max number of threads or something like this. We should probably add this somewhere as a constant, and rather than hard coding 2, which is a little bit squirrely, although we do sort of hard code the starts down here. Why do we have to reassign this every time? Because process is called multiple times. If you look at the test program, you'll see that process is actually called in a loop. So it needs to reinitialize the countdown latch each time it starts up. So that's where we do it. So we started out with a count of 2, and that's because we have 2 threads that we're going to wait on here. Then down here, we go ahead and we create the ping and pong semaphore. Now, in this particular case, I'm going to make a little change here. We don't need to make the semaphores be fair or not. They can just go ahead and start out in an unfair order. That's going to run a little bit faster. So that's a better way to go. And we want the ping semaphore to start out unlocked, so we give it a count of 1, which means the ping thread will acquire it without blocking. We want the pong semaphore, however, to be blocked. We want it to start out locked, so we give it a count of 0. Now, people had asked the question for the last assignment for simple semaphore, should the semaphore check to see whether or not its count is greater than the initial value passed in as a parameter to the constructor, if you recall that discussion. Here is a very nice example where we don't want it to be doing that check, because in that case we'd never be able to increment this thing greater than 0. So this is just a canonical way people start semaphores out to be locked. They just give them an initial count of 0. And lots of semaphore implementations work this way. The POSIX semaphore implementation works this way. The Java implementation of semaphore works this way. I believe the Boost implementation of semaphore works this way. The ACE version of semaphore works this way. So that's yet another reason why you don't want to have that check in the semaphore release method, because it wouldn't make it work this way. And that's how they all work. We then go ahead and print the start string, and then down here we create 2 threads, a ping thread and a pong thread. They are both play ping pong thread objects, and they pass in the appropriate string, either the ping string or the pong string. And the play ping pong thread that's used to make the ping thread passes the ping semaphore in first, which means it's going to acquire it, and the pong semaphore in second, which means it'll release it. Conversely, the pong thread passes in the pong semaphore first, which means it's locked, followed by the ping semaphore, which means that it'll be released. But of course, it won't get to that point till the other guy has locked it. So that's how we end up being able to alternate going back and forth between ping and pong threads, and that's how we ensure the ping thread always starts out first. If you try to do something with one semaphore, you will very quickly realize that it's hard to guarantee that the right semaphore always begins without doing all kinds of crazy non-portable stuff. Down here then we go ahead and call start on the ping and pong threads. That means the threads are running. And then the last thing you have to do, of course, is you need to wait for all the threads to finish. And when you're done, then you go ahead and print out the finish string. And that's basically what it does. The main program here, as you can see, just prints ready, set, go as the begin string. It prints in ping exclamation point as the ping string, and pong exclamation point as the pong string, and then it prints the done, and it gives max iterations and m max iterations. So that's basically how this solution works. Let me see if there's anything else that's worth talking about here before we go and answer questions. So the main thing is that you call a wait at the end in order to wait for the threads to exit. Now, we could have done this particular solution by saying ping.join and pong.join. That's also another solution that for this particular case would have worked, and we could have done away with the countdown latch altogether. Why did we not do this? Well, the main reasons that we didn't do the joins was we'd already done joins in the previous assignment, and so there was no need to repeat that. This particular assignment was released at the same time the video on countdown latches was released, and so I wanted people to become accustomed to how that would work. So I was trying to give people a chance to practice with countdown latch, because that was one of the topics we talked about. And then the other reason was that when we do the next programming assignment, which is what we'll talk about shortly, wanted to make sure that people understood that countdown latches are a more general way of waiting for things to exit. And we wanted to do that because it helped to address some issues with running the code in both Android and Java at the same time. So this was just a couple of different reasons for using countdown latch, even though strictly speaking, we could solve the problem in a slightly different way. Okay, so now that we've gone over my solution, let me go ahead and answer any questions that you have about these particular topics, and we'll see how this all goes. All right, so first question. If countdown was inside the loop, is it okay that countdown latch constructor has 2 times max iterations? It certainly will work, all things being equal, assuming there are no bugs. I wouldn't recommend doing it that way, but there's no need to take points off as long as the program works. As usual, our grading rubric in this class is biased towards correctness as opposed to efficiency. It's always easier to come back and add efficiency later, usually, than it is to add correctness later. So it's better to optimize for correctness. Even though I would leave a comment, if somebody does the countdown latch inside the loop and it has 2 times max loop iterations, I would put a comment reminding them that they don't need to do that. It's not strictly necessary. Countdown latch versus join. Wayne asked about countdown latch versus join. Exactly, that's what we just talked about. I was using countdown latch here primarily to give people practice with countdown latch and also to get you ready for the next assignment. But it's not strictly necessary. And in fact, there was an interesting discussion we had with Martin on the discussion forum who argued he would put the join in anyway as sort of a debugging aid to make sure things actually did in fact finish, which is a sensible thing to do on some circumstances, although I didn't want to do it here because it would have caused more confusion probably. Let's see. It appears that you set excuse me, M string to print is final. I cannot assign string to print. You should be able to assign the string to print. A final variable can be assigned inside the constructor, so you should be fine to be able to do that. Certainly my program compiled with that in there, so it works. Is it correct to call acquire rather than acquire uninterruptedly? Well, not really. Excuse me. I would recommend using acquire uninterruptedly because otherwise you'll have to handle exceptions and your program will get more complicated. And then you'll also have to make sure you put the try catch block in a loop, etc., and various other things can go awry. Now, having said that, if somebody used acquire instead of acquire interruptedly, and they handle all the corner cases correctly, and their program would terminate if they had an exception raised, which of course the program doesn't raise an exception, but if it did, then you can take that into account. I wouldn't necessarily count off as long as people knew what they were doing, but it's way more complicated to use to use acquire than acquire uninterruptedly. So people really should use the right one. Countdown latch await was placed in a synchronized block for the statement. Will this work properly? I'm not quite sure. Will, I'm not quite sure I understand your question. Let me see if I can go back and look at the code and try to understand what you're saying. I'm not sure if you were saying, should it be placed in a synchronized block or was it placed in a synchronized block? If you take a look here, this is just a good old static method. There's no particular anything going on here. Maybe you're asking, should it be in a try finally catch block? There's nothing here really that's going to throw an exception, so I think we're probably okay the way it works. But if you want to clarify that question somehow, I'll be happy to take a shot. Or if you want to write it up on the discussion forum, I'll be happy to take a shot at it. How do you run the assignment as a console app from Eclipse? I will show you how to do that in a minute. Don't let me forget to do that, Sergey. Why is it not necessary to use an exception handler at M08? I don't think it throws an exception. At least it doesn't seem to. Is correct write while? No, you shouldn't have to say get count greater than 0 and then call await. Await basically does that internally, so it's overkill to do that. Yes, if there's no try finally and run, it's acceptable. That should be fine. 4 of my 5 peers have poor simple semaphore implementations. Yeah, just Mark asked a good question about if people didn't go back and fix their semaphore implementations. I didn't want to burden graders to have to go back and recheck the work, although in retrospect we probably should have, because that would have indicated people didn't go back and fix their bugs. In practice, if you were to do this in a production system, after someone gave a code review of your code and you didn't fix the bugs, that would probably be looked upon very unfavorably by the senior developers and architects and managers to not fix your code. But we'll let it slide in this case, but it's definitely something that you should think about carefully in terms of your own personal coding habits and processes. Make sure that you're not willfully putting out code that's known to be wrong. Let's see. Another question about acquire interruptedly. Yeah, so this is another question saying if acquire is called instead of acquire interruptedly, is that okay? Well, it's okay as long as people handle things properly. The reason why I didn't use it was I didn't want to have to open up this giant can of worms about handling the interrupted exception. So the minute people start using methods that require interrupt exception handled, there's a lot more work that has to go on, and it's really unnecessary for this particular assignment. So I'll let you, the graders, decide what you want to do with that, how much effort you want to do to make sure it's correct or not. Good point. Charlie makes the point. That's right. The process method declares the interrupted exception. Let me go ahead and show you this because it's important to understand, including myself. Let's go find this thing and bring it up to the forefront. So if you take a look, you'll see that the process method throws interrupted exception, and so as a result, we don't have to catch interrupted exception. Now we shouldn't be getting interrupted exception, but if it were to be thrown, we would catch it. So that's one way to do it, is to kind of punt up to the guy above and make it that guy's problem. Another way to do this would have been to do something like this. Let's do a try block, and then we'll come down here and we'll say finally. So this time we get rid of the interrupted exception, and I guess we could put a catch block in here. And we could do something or other in this particular case. In the case that we have the interrupted exception, we could print the stack or whatever we need to do in that case. ... And now we're handling it inside of process, and it's no longer the caller's problem to figure it out. And you know, there are different pros and cons with the different ways of doing this. Let's see. Let me go ahead and get rid of that editor for a second so we don't see that. It's try finally block. Yeah, Sheila, try finally block is okay, not a problem, as long as, of course, you make sure you release the countdown latch. All right. Okay. Lots of people asking the same question. The answer is it's fine to do it, but you don't need to because the process method throws interrupted exception. It's certainly fine to get rid of the new interrupted exception. That was just there to get your attention so you do the right thing. Yes. The point about finally, if you're going to have a final, sorry, the point about final, if you're going to have final, then you shouldn't declare it. You should go ahead and declare it in the constructor. Let's see. Some people, this is the recurring problem, just to reiterate this for the umpteenth millionth time. The solutions we put up ahead of time in beta mode are for people to play around with and give us feedback on what to improve. That is likely to change. In fact, it almost invariably will change prior to the official release. And the reason for that is we don't have access to everybody's platforms. We don't have the wisdom of the crowd. So sometimes when we put the beta versions of the assignments up there, they have mistakes in them, which are inevitably caught very quickly by people who take a look at that. And then we endeavor to get those fixes included for the, quote, official release, which goes out certainly by Monday morning, if not sooner. And the official releases, of course, are what goes out on the course website, right? So the course website through the peer assignment and assessment link, that's a pointer to the official version. That's what people should use. It's fine to download the earlier versions. In fact, we appreciate people to do that, to give us feedback, to fix things that are broken. But you should also make sure that you then download the official version. When people don't do that, it causes a lot of headache for everybody. And so it's fine to be lenient with people if they downloaded a version that had some changes that were fixed by the final version. You know, if it looks like it works, then you know, give them the benefit of the doubt. But people really should follow those rules. You might wonder, why can't we just get the solutions perfect the first time? Well, again, it's very hard to do that when people have all kinds of different versions. We had a problem with last week's assignment, or the assignment that went out this week, where for some versions of Eclipse it worked fine, but for earlier versions of Eclipse it didn't work fine. And we had been using newer versions of Eclipse, so of course we didn't know that. Once we put the beta version out, people found the problem, we fixed it very quickly. The version that went out on the web had that fixed. That's great. But that's why we give ourselves this beta period for people to try to fix things. So I guarantee you there will always be things to improve, and by having a beta release we can minimize the headache for most people, as long as they follow the simple rule to either be willing to update once the official version comes out, or if you don't want to do that, just wait until the official version comes out and then download that. So that's kind of the bottom line. It's fine not to define semaphores as private. Final, that's okay. Doesn't really change the correctness. As you can see, the overriding theme that we emphasize here is getting code that works correctly. If it's sometimes not as efficient as it could be, that's okay for these purposes, for teaching purposes. If you don't put final or you don't use the right access control specifier, that's okay. But I would say if someone doesn't use those things, give them some feedback, encourage them to go and fix the code. That's the main goal, is to get it right. Once you get it right, then you can do other kinds of optimizations. Change the two-element array to an alternative, two independent member variables. Well, that's like really very simple. Let me show you that real quick. It's like falling off a log. All we should have to do in order to make this particular thing work is just go up here. So the point was, rather than having there be an array, we would just say, you know, private final simple semaphore m sema 1, or how about m sema first and m sema second, like that. And then of course down here we would replace all the places where we're assigning m semaphores first sema with m sema first, and everywhere we're assigning m semaphores second sema with m sema second, and that would hold down here as well in acquire and release. And that's really all there is to it. Basically the same idea, just explicitly defining these things as opposed to using an array. But it's essentially the same difference. Okay, let's see. Got some more questions. Some of my peers uploaded the wrong semaphore. The test passed, but the implementation is incorrect. So the question is, does their implementation make the solution incorrect even if the test doesn't reveal the incorrectness? If that's the case, then I would count some points off, because just because the test doesn't show there's a bug, if there is a bug, you should take that into account. So question, if they didn't re-include their version of Simple Semaphore, if someone didn't include their updated version or a version of Simple Semaphore, then that should be a point off, because I think one of the things was that they had to upload it and it had to compile. Let's see. Nicola has the observation, the green background is creepy. Yes, the green background is creepy, and the good news is sometime later today or early tomorrow, when you download the version of this video that's been post-produced, the creepy green background will be replaced by a nice, pleasant blue background, which will be very relaxing, and when you watch the virtual office hours with a nice, pleasant blue background, you'll feel a lot less creepy. But I need to use the creepy background now because otherwise I can't go back later and easily remove it and replace it with a nice, pleasing background. So that's kind of the reason for that. Okay, so that was actually all the questions for this particular assignment. What I'd like to do now is go ahead and go through the skeleton for the next assignment. And that will give us a chance to take a look at sort of how what we did this time builds on what we did last time. All right, and I'll come back and answer any questions that I didn't get to earlier as soon as we're done with this. What we're going to do now is we're going to take a look at the implementation of the Android version, and we're going to take a look at the skeletons. So first, let's see how this thing would work. Let me just double check to make sure that this is actually showing up. Yes, it is showing up. So here's the main program. The main program is what's called if you run the application from the console. So if you run the application as a console application, the main program is called. What it does is it goes ahead and it creates the appropriate factory object. It calls the platform strategy factory to make the appropriate kind of platform strategy, which is, this case, is going to be the console strategy. Let's go take a quick look and see how that works. Here's platform strategy factory. Platform strategy factory basically is a factory that has a factory method called make platform strategy, and it uses the command pattern to create a map, and the map contains a set of commands. Here's the interface of the commands. As you can see here, it has an execute method, and we make a hash map that will contain these things. And in the constructor of platform strategy factory, it takes the parameters passed in for the output and the activity, if there is one, and depending on what type we have here, whether we have the Android type for the platform or just a plain old Java type for the platform, which we show down here, it'll go ahead and it'll make a new command object whose execute method will either return the Android platform strategy or the console platform strategy. And so those things are put into the map at startup time, then it runs. When make platform strategy is called, it'll go and figure out whether it's an Android platform or a regular old Java platform. We could actually probably do this in the constructor and cache that information away because it doesn't change at runtime. And then we use that information and we execute the appropriate command object, and it makes the appropriate type of platform strategy. Here's what a platform strategy looks like. Platform strategy is an abstract class, and the key thing it has is a bunch of methods: begin, print, done, and await done. And those are all abstract, as you can see here, which means they have to be filled in by subclasses. So if you take a look back at the main program here, when we call make platform strategy, it'll make ourselves a console platform strategy because this is the main program that we're using here. And then if we go up and look at console platform strategy stashes away the system out object as part of the print stream. And then it has begin, print, done, and await done methods. And what the begin method does is it makes a new countdown latch that's initialized to the number of threads, which in this case is 2. It has a print method that prints to the output. Keep in mind that if you run in console mode, multiple threads can write to the output at the same time, which is different, by the way, from what Android does. Here's the done method. The done method calls countdown on the latch, and await done simply waits for all the other threads to exit. So those are the methods that are filled in for console platform strategy. Once main does this, it then goes ahead and creates a new ping pong object, passing in the appropriate parameters, including the platform strategy and including any options that might have been set. And then we go ahead and we create a new thread. And that thread will then run the run method on the play ping pong object. So let's take a look now at play ping pong thread. Here's play ping pong thread. It is a runnable, which means it has a run method. And here's its run method down here. When its run method gets called, it tells the platform strategy that it's starting. It then prints out whether it's it prints out that it's starting, saying ready, set, go. It creates 2 new ping pong threads. We'll look at those in a second. it initializes these ping pong threads using a factory method that we'll look at. Once the factory method initializes it correctly, it goes ahead and starts both threads, and then it waits for them to be done. And when it's done, it goes ahead and prints out done. Notice that this code shows no details as to whether this is running on Android or whether it's running on the console version. It has exactly the same code, and that was the whole purpose of using the platform strategy, using a strategy and using a factory to make the strategy for the platform, was to factor out all that logic, so it's not showing up in the main piece of code here. Okay, let's now take a look at some of the implementation details. Here's some of the sort of data members we've got. Here's the ping pong thread class, which is an abstract class that extends thread, and it implements the template method pattern. Its acquire and release methods are used by the run algorithm to be able to acquire and release whatever kind of lock is being used here. And we'll look at this in a second. And it's got some other helper methods to do various other things. Here's the main workhorse of the play ping pong thread abstract class in the template method pattern. As you can see, it goes into a loop and it acquires the lock, it prints out whatever needs to be printed, and it releases the lock. Notice the way that the template method pattern works. This fixes the steps in the algorithm here, but allows us to vary acquire and release by subclassing from play ping pong thread. There's an interesting combination of patterns here. We're using template method to vary the locking mechanism, and we're using strategy to vary how it is that we print stuff and how we synchronize. We could have also used strategy for everything, or we could have used template method for everything. I just wanted to show that the two patterns could be used interchangeably. When we're done, we go ahead and indicate that the thread is done playing ping pong by calling the done method. Once again, you'll notice there's no platform-specific code here at all. It's all abstracted away into platform strategy code. Here is ping pong thread sema, which is just a variant of the implementation of the previous programming assignment. As you can see here, it makes a pair of semaphores, which it initializes to the constructor values, and its acquire and release methods just acquire and release the semaphore pretty much identically to the way it had been done in the previous assignment. So this is pretty simple. The main difference from the previous assignment is the previous assignment did not use template method, whereas this one does. So it defers those choices to further down. Here is play ping pong thread condition, which is also a subclass of play ping pong thread, or a ping pong thread, sorry. That makes two condition objects and a reentrant lock, and it has some other fields it uses to allow the ping or pong to be printed multiple times each iteration through the loop. Here's basically what the constructor does. It initializes the various pieces based on what's passed in as parameters, and its acquire method is somewhat more interesting, and its release method is definitely much more interesting than the one we used for semaphores. As you can see here, its acquire method grabs the lock, and then while it's not the thread owner, it waits to become the thread owner. So by default, the ping thread starts out being the thread owner, and the pong thread starts out not being the thread owner. So as a result, ping runs first. When something is done, release is called. Release decrements the iteration count, which keeps track of the number of turns that a thread has gone through, which defaults to 1, by the way, so it behaves just like the thread semaphore by default. But you can make it be higher than that. If the iteration count is equal to 0, that means we're done with our turn, or our turns, and we make the other guy the thread owner, and we give the other guy the maximum number of turns to run, and we signal the other condition object that we are done and they can start. And of course, we unlock the lock. So what will happen here is that these conditions take turns signaling each other, but the actual condition is much more sophisticated than the one that used the semaphore. So that's basically how that works. Here's the constructor, just initializes various fields. Probably one of the more interesting methods in this whole thing is the factory method that's called make ping pong threads. That's passed in an array of ping pong threads, the 2 of them, and a string that keeps track of whether we're doing things with semaphores or conditions. And if we do things with semaphores, the implementation looks pretty much identical to what we had done in the previous assignment, creating one semaphore locked and the other unlocked, and then passing them alternatively into the ping pong thread semi-constructors. If it's condition objects, it's more sophisticated because we have some additional work to do. First, we go ahead and initialize the conditions from the lock and then we pass the conditions, and we pass the lock into the ping pong thread condition constructors, reversing the order of ping condition and pong condition so that they'll alternate properly. And then we set the thread IDs properly as well, so they know how to start the threads. And that's basically then the run method we just looked at a minute ago, and it uses the results to come back from make ping pong threads in order to make the appropriate ping thread and pong thread. Okay, so that's how things work for the console version. That's also how it works in general. Now let's go take a look at the Android version. The Android version uses an activity, of course, and its onCreate method basically goes ahead and does some user interface related stuff. And then its onCreate method does a few things that were also done by the main method in the console version. In particular, it creates the appropriate kind of platform strategy. You can see they're identical. And then it goes ahead and it parses the arguments, which vary a little bit, but same basic idea. When someone actually presses a button to play the game, the play button clicked method gets called, and that basically does the operations that are done at the bottom of the main method here. It goes ahead and creates a play ping pong object and then starts it, and that goes ahead and starts to run. So the only other thing here that's worth understanding, and this is the most important thing because it's what you actually have to implement, is the part here that implements the Android platform strategy. So we took a look before at the console platform strategy, and we saw how that worked. And now the Android platform strategy is also a platform strategy. It's created by the Platform Strategy Factory, and what it's going to be passed in is the text view for the output and an activity which it's going to use as a weak reference to get access to the appropriate parts of the activity. Most importantly, its run on UI thread method. And when I show you my final version later, I'll show you how I updated it to use a weak reference for the text view as well. And I just didn't modify this for the shells because I didn't want to confuse people. These are the methods you have to implement. You have to implement begin, print, done, and await done. Begin is very simple. It's basically the same as it's done for the console platform strategy. Await done is very simple. That's basically the same as the console platform strategy. Print is different because we can't have background threads in Android printing to the console, so we're going to have to create a runnable and use the activity weak reference as a way to post that runnable to the user interface thread by calling run on UI thread. And the done method down here can be done in one of two ways. You can either call run on UI thread and pass a runnable that will decrement the count, which is how I did it because I wanted to make sure everything else was done before I decremented the count. Or you can just go ahead and call done, or call the countdown latch directly here if you want. Okay, so that's basically an overview of all the parts of that solution. Let's see if people have any questions about this now that we've actually gone through it in a way that you can see. Hopefully that works better. Oh, good question. So is there a reason why we use condition objects in acquire and release for Android rather than for semaphores? Well, we don't use condition objects in acquire and release for Android rather than semaphores. If we go back and take a look at this, let me bring up the editor again, and this is really important to understand. The use of condition objects or semaphores, which we see here, is completely independent of whether it's running on Android or not. So all the code that you see in the Play Ping Pong implementation is platform independent. This code does not care what platform it runs on. And the way it does that is by using those platform strategy objects to print and to synchronize the shutting down of the threads and the starting of the game. The ping pong thread condition and the ping pong thread sema, both those classes are easily usable with Android or not on Android. It's completely independent. You can do it either way. So you should be able to make that choice. Okay, let's see. Hopefully we've addressed all the questions there. Let's see. I would never think to implement this solution using all these patterns. Well, that's probably true. Most people who were implementing play ping pong thread would not have used all the patterns. I did it for two reasons. Number one, I wanted to be able to show how to write code that could work independently of whether it was running on Android or whether it was running on the console application. So that was one reason for using the patterns. And secondly, I wanted people to learn how to use the patterns. So what better way to learn how to use patterns than to see them actually applied in practice? And you can take a look at the code, you can play around with the code, you can modify the code, you can watch the videos, and so on. So absolutely, I wouldn't expect people to do that out of the box. Just like I wouldn't expect my 7-year-old son to know how to do calculus or differential equations, because he hasn't gotten to the point in his education where those things are important for him to understand. But of course, once he gets to that point, hopefully he'll learn that and can use it. Why are these locks used without try finally? Because we're calling the versions that don't throw exceptions. Let's see. Is it okay to use view post instead of the some activity run on UI thread? That's actually a very good question. They end up doing exactly the same thing. I would in this case kind of favor using the run on UI thread because I think it's a little bit more clear what's going on, but obviously other people might feel differently. So I don't feel one way or the other. It sounds like Netherlands is doing so. Anybody tell me the World Cup score? That'd be fun. Let's see. Would you say the reusability that's built into this code would facilitate adapting it from ping pong to World Cup football? That's a good question. That's probably an extra credit assignment for people who want to score additional points, is to modify this. I'm actually trying to see how I could teach the entire class using nothing but examples from the Lord of the Rings. Let's see. Someone says we're not seeing the code. We probably already dealt with that. I have no idea how to do this week's homework assignment. All right, we've hopefully covered that. I'll edit this. You've mentioned about not using if statement but a while loop to check for conditions when synchronizing locks. I'm still not clear when one would apply if versus while in the process of synchronizing. Please explain. So let's see. So the discussion here, which was actually covered at length in last week's virtual office hours, but I will recap briefly, Wayne, for the purposes of the discussion. If you're using condition variable, check a condition prior to using the condition at all, the condition object. And that's, of course, because if the condition is true, there's no need to wait. If the condition is false, you must check that condition in a loop. So that when you go wait on the condition, and then later somebody signals you to wake up again, you'll grab the lock that's done for you, and you can loop back around again and recheck to see if the condition is now true. Because it's possible that even though you were signaled, the condition you're waiting on may no longer be true, or the predicate that you're waiting on may no longer be true by the time you loop back around. And that has to do with the inherent non-determinism of multi-threaded programs. So I encourage you to take a look at the videos on condition object, take a look at the videos on condition object, take a look at the videos on built-in Java monitor objects, both of which talk about this need for a loop, and also follow the links in those discussions to the Java documentation that explains further why you need to call those things in a loop. If that wasn't something that helped, please re-answer it again. Craig asked a question. Why did you send the text view and the weak reference to the activity in the Android platform strategy? Couldn't you get the text view reference from the activity using find by view ID? We probably could have done that, but we were trying to be consistent with the interface that we were using to pass in the output objects. Believe me, there are a lot of different ways to solve this particular problem, and I'm not going to claim that my way of doing it is the only way or the best way. Your mileage may vary. I didn't okay, this is a question from the earlier discussion about the grading of the solution, the week 4 assignment 3. Should we add a try-catch block in process? It is not a mistake. You can add one if you want, but it's not a mistake. All right, we've answered that. We've got the code. let's see. If you slow down the printing of Ping and Pong, you can press reset and then start a new game and get several games running at the same time. Shouldn't the call to reset kill the current game? Yes, probably should. That's a good thing to add as a feature. Juan asked the question, what kind of patterns are used in this assignment? I'm not sure which assignment you're referring to, but assuming you're referring to week 5 assignment 4, which is the one that's the first Android and console version. If you watch the videos for that, which are in week 2 under the Java synchronization and scheduling example videos, there are 2 of them. The patterns that we really focus on there are template method, strategy, and factory method. Of course, there are lots of other patterns. There's singleton pattern going on there. There's the guarded suspension pattern that's going on there. And I didn't draw attention to every single pattern that we used, but the 3 big ones that we used to structure the overall design, to make it platform independent, to make it possible to change the synchronization mechanisms, all of those things are based fundamentally on template method, strategy, and factory method. And I mentioned you could also use component configurator if you wanted to, although I didn't go that far. Observation regarding if versus while. Let's see. Oh, I didn't get the rest of that question. Oh, okay. People don't want to know don't want to find out the score of the game. Well, okay, I won't say any more. I don't want to spoil the time zone issues. Last time the World Cup was played, I was actually in India, and so I got to watch it in real time, which was kind of fun since it was in South America. Let's see. At the lowest level, are all the threads in our Android application basically working the same as threads in the Linux desktop, since Android is built on top of Linux? Yes, basically. If you go back and you take a look at the very first video from week 1 on Java threads, I think it's the second video. Actually, it's the second video on Java threads. I walk through exactly what happens when you call start on a Java thread. I walk through every single call it makes all the way down to the pthread create method. So if you want to see exactly what is going on under the hood in your virtual machine, or at least the virtual machine when I recorded the video, which can always be subject to change, then go take a look at that video. It's Java Threads Part 2, and it shows exactly how those things work. And let's see. For pure assignment purposes, I read somebody talking about hard coding the strings, and it's wrong. Let's see. I don't think it's actually wrong. As long as their solution works properly, I don't think it's wrong. That's great. Van der Bilt. A lot of people from Europe think it's Van der Bilt, and that would be sort of the Dutch or German way of doing things. That's pretty funny. Another question asking whether to use run on UI thread versus view post. Either one works. I have a preference to run on UI thread. I just think it makes more sense. It's more generalized. Why are you creating static classes? I'm usually creating static classes for one of 2 reasons. One of 3 reasons. Number 1, I want to be able to use the weak references trick in order to be able to avoid circular dependencies that preclude garbage collection. That's one reason. That's talked about in the videos. It's also described on the discussion forum over and over again with pointers to more information. Second reason, I'm too lazy to split it off into its own file. Oftentimes things belong in a file. They don't really belong public, and so, or they don't belong as a separate file. They're not a separate abstraction, so I make them static. And other times, I'm just too lazy to do it some other way. But usually it's the first 2. Let's see. Why do you use a weak reference? So the question about Craig, the question about weak references is discussed in the videos. If you go and watch, it's discussed several points of time. One place it's discussed is in the programming with the Android concurrency frameworks video part 2. So programming Android concurrency frameworks part 2, when we talk about, I think it's the very first example that uses the Hammer framework. There's an example of using weak references. And if you take a look at the video, it explains it, and it has a link to an article that talks about why. And the reason why it's done is to ensure that garbage collection is done properly, to avoid circular dependencies. There's also a really nice explanation of this in the discussion forum by Mitchell Gordon, who's one of the students in our class who's helping out with preparations for the assignments. He has a really great explanation of how all this works. I have 2 different services or pieces of code operating in the same process, other than the main process. We only need to specify that in the manifest file and then have the same process name. So yeah, there's a whole discussion about naming processes and that in the Android documentation on services. Take a look at that. It should explain it. In programming practice, do you see async more often than posting runnables and sending messages? Sheila, I assume when you ask that question, you mean async task versus posting runnables and sending messages. I would say I see it about the same amount. If you were to grep the code of the Android source code, you would see lots of uses of async task. You would see lots of uses of the Hammer framework with posting runnables and sending messages. They're used pretty much equivalently. The video that I recorded, again, on programming Android concurrency frameworks, part 2, has a comparison of the pros and cons of each approach. And so use whichever one you like. I personally like async task a little better because I think it's cleaner and more object-oriented in some ways, or more pattern-oriented. Well, maybe they both use patterns. It actually gives you a better abstraction for those patterns. But if you watch the video, it gives you the reasons for using one versus the other. I made Pong start before ping, yet the output is still in the same order. Yep, that's absolutely right. That's because the semaphores are what are dictating the order in which the threads run, not the order in which the threads themselves are actually started. How about running the first one with console? Hopefully I've already done that. Let's see. Oh, here's a question from Chad. I received feedback about my implementation of the long integer. I decided to use +1 plus equal 1L. So the question is using plus equal faster or slower than using plus plus? A good Java compiler should make those 2 pieces of code run absolutely 100% identically. Plus equal 1 versus plus plus, you should see no difference in performance. It's more an issue of what do people expect to see. If I'm reading code and I see plus plus, I pretty much know what that person's doing. They're incrementing the variable by 1. If I see plus equal 1L, I've got to stop and scratch my head and think, why are they doing that? And so it's not wrong. It just takes people a little bit more time to figure out that it's right. And since code is read a lot more than it's written, it's best to try to optimize the code for readability and understandability from an idiom point of view. Plus is arguably easier to write than plus equal 1L. It's 2 less characters. When is it appropriate to use a stop mechanism for runnables that we create in our assignments? So Craig, I'm not quite sure what you mean. I think what you might mean is should you worry about terminating things if they run too long or something like that? For the assignments that we're doing here, hopefully they run for a relatively short fixed amount of time so they don't take over your computer unless there's a bug, in which case you can shut them down other ways. In general, if you go back and watch the video on Java threads, part 2, it talks about how to stop threads. You can either have a stop flag that's a volatile, or more likely you can use the terminate method on the thread to tell it to stop. And those are the most common ways of doing things. There are also ways of doing it calling the deprecated stop method, but that is highly not recommended. And certainly for our assignments, you shouldn't be doing those kinds of things. Specifically regarding that it's a long, which actually takes 2 operations to increment. So whether you use plus equal 1L versus plus plus makes absolutely no difference whatsoever with respect to the issue about multiple operations to increment. If you want to make sure that it takes multiple operations to increment, you've got to use a whole different mechanism to protect against that. So even making it volatile will not help you in that case. So if you want to make sure that plus plus or plus equal 1L actually operates correctly in a multi-threaded environment, you've got to protect it with a lock. That, of course, is exactly what we used for our simple atomic long operation, where we used the read-write locks that Java provides. Let's see, Neil's asking a question. When and why would you run a task like downloading an image in an Android service rather than posting a runnable in a background thread? Great question, Neil. I'm actually working on a video that'll probably come out, that might come out later this week or it'll come out next week, that talks about this. And here's the long and the short of it. If you go and take a look on the discussion forum, there's a discussion about this topic, and you could find a link to what I'm about to talk about. But in a nutshell, the reason for putting it as a service is if you want to be able to package it up and allow other applications to use it. That would be the most common reason for using a service, because you want to be able to make this functionality something that other applications can use. And you might even want to make it so that other non-activities can use. Keep in mind, when you use an async task, the async task must be invoked from the user interface thread. Whereas if you make something a service, you can actually have a background thread invoke a service, or you can have another service invoke a service, etc. So it does not have to be invoked from the user interface thread. So that would be sort of one of the reasons for doing it. The other main reason, though, is you want to be able to package it up and reuse it as a standalone component that can be reused. Whereas if you put it in an async task, then it's much more difficult to do that because there's limitations on the context in which it can be used. By the way, what I'm about to do is make a couple more videos where I take some of the examples that Adam Porter used in his class. Like he has an example in his class where he downloads some information from a web service using an async task. And so I'm redoing this as a bound service and illustrating how you can use bound services and AIDL and the binder framework and so on and so forth to make a reusable service that you could use for many applications as sort of a mediator to access a web service. So that would be an example of using things as a service. So the bottom line is use services if you want to package up the application, pack up the logic so they can be reused by other things. There's a new announcement about a plan to show an example to compare and contrast use of services as async tasks. Okay, so I think I've explained that. Bottom line is services are more useful to package up stuff for use by applications as standalone components, whereas async tasks, surprise, surprise, are not standalone components. There are now lock-free increment operations, at least in C++. Yes, Alex, there are indeed lock-free increment operations in C++. In fact, if you take a look at the simple atomic long or simple atomic int implementations in Java/Android, they use those operations. Our particular implementation doesn't do that because we were trying to show the use of read-write locks. But if you take a look at the source code, which you can always access from the website, you'll see that that's indeed what they do. Okay, looks like we're running up towards the end. What I will do is I will go back as soon as this video is finished rendering, and I will split it, and I will take out the part where there's no screen, and I will replace it with the part where there is a screen, walking through the code. And so at some point later today, it surprisingly takes a very long time to download these gigantic files and edit them and put the green screen replacement so it doesn't look creepy in the background and all those kinds of things. So it takes a little while to do that, but certainly by tomorrow morning, if not later tonight, we'll have a new version of the virtual office hours with all the things put in the right place. Okay, any other questions before we call it a day? Thank you, Chad. I always enjoy virtual office hours. It's one of the most interesting and I think somewhat innovative aspects of this course is the ability to interact with the students live, trying to take a medium called a MOOC, which inherently is designed to be very static and make it a lot more like a real face-to-face class. So thanks again very much for participating, and I will look forward to talking with you more on the discussion forum. Thanks.